Hello, welcome to our Intro to Aerospace Glider video. I am Bonglu Wei.
And I'm Adetola Saizonu.
Our objective during this project was to make a glider that can fit in a 16 by 16 inch box and fly 20 feet. First of all, Adetola will be going over our initial design and construction process.
The requirements that we identified were the following. Firstly, controls. The glider must solely rely on being hand-thrown for its flight with no remote-controlled components. Secondly, structure. The glider must not break apart during the flight, and it must be able to stay intact for the duration of the flight competition. The glider must also be primarily made of balsa wood. Thirdly, size. The glider must not exceed the confines of a 16 by 16 inch space. And lastly, performance. The glider must cover a minimum straight distance of 20 feet without deviations in pitch, roll, or yaw. As for the initial concept, we decided to go with a delta wing glider. However, we got advice from a TBF member who told us to instead try elliptical wings. As for the alternatives, the first category is wings. We decided to look at elliptical and delta wings. The advantages of the elliptical wing were that it had a higher aspect ratio, which led to more stability and less induced drag. However, the disadvantages were that the smaller area led to higher stalling speed. As for the delta wing, the advantages were that the larger area led to lower stalling speed, and the disadvantages were that at low speeds, delta-winged vehicles require a high angle of attack. They also have a low aspect ratio, which is not convenient for gliders. Due to that, we decided to choose the elliptical wings as it's the most efficient platform of all high aspect ratio wings. Second category, dihedral. Without the dihedral, we would have less stability, and with the dihedral, we would have more stability. However, adding a dihedral was not easy and proved to be difficult to build. Therefore, we decided to just go with no dihedral, since due to the poor manufacturability of our material. As for the third category, adhesives. We had three options that we were going over: Elmer's glue, super glue, and Scotch tape. The advantages of the Elmer's glue was that it was appropriate for porous material such as balsa wood. However, it takes a long time to settle, which significantly delayed flight testing. The super glue, on the other hand, dries pretty quickly, which allows for near immediate testing. However, it makes it quite difficult to disassemble once it's dry and adjust the components. The Scotch tape easily allowed for changes to be made to the glider. However, it's a poor adhesive, it comes off easily, it's not secure, and significantly affects the weight of the glider. Sizing. We decided to use a canard configuration for our glider to provide additional lift and stability to the main elliptical wings. As for our wings, to achieve high aspect ratio, we decided to use the maximum 16 inches for our wingspan. As for the fuselage, while a longer fuselage would have provided more stability to our glider, it would have added to the overall weight of the glider, so we decided to have a fuselage to span ratio of approximately 1 to 2 with 8.8 inches. As for our stabilizers, we had horizontal and vertical stabilizers, which were all tapered, standard tapered wings, with the horizontal stabilizers being about 20% of the wing area, and the vertical stabilizers being 30% of the wing area for ease of manufacture.
After we glued the aircraft together in its initial configuration, we took it out to the tech green to conduct some further flight tests. Unfortunately, the aircraft very quickly pitched down and hit the ground due to the center of lift being too far back compared to the center of mass. As it was though, the glider could most likely make 20 feet by flying in a parabolic arc, but we wanted to make sure that this goal could be met easily. We taped a second, slightly larger canard underneath the first, effectively creating a biplane canard to increase lift at the nose. On flight day, the glider continued to pitch down during its first and second official flights, at which point Adetola and I applied a small amount of Play-Doh to the very rear of the aircraft to shift the center of gravity rearwards. This noticeably improved performance despite despite the glider having sustained damage to the canards. Ultimately, the glider was able to make 40, 33, and 45 feet, and it was able to fit inside a 16-inch by 11-inch rectangle, and lastly, it was able to consistently fly far beyond 20 feet, thus meeting all the specifications. The final configuration of the glider had the following specifications. Overall, this was a very fun and educational project that nonetheless showed the challenges of applying theoretical knowledge onto a real-life model aircraft. If finals were not rapidly approaching, it would most definitely be fun to incorporate a series of further iterations to see if they improve the aircraft, such as implementing one larger canard, increasing wing area or aspect ratio, and altering the fuselage to decrease weight and drag.